2 is a straightforward integration problem. In part A, we're asking to integrate sine to the 5 times cosine squared. How do we integrate a product of sine and cosine? We look at the exponents. Is one of the exponents odd? Indeed, the exponent of sine is 5. This is odd. What does this tell us? We split one single factor of sine off and write the rest in terms of cosines. So let's do this. Let's split our one factor sine of x off. What are our remaining factors? Now we have a sine to the 4. Sine, that's sine squared squared. Times the cosine squared of x dx. Okay, now next we need to write this sine squared squared in terms of cosine. We know that sine squared is equal to 1 minus cosine squared of x. So that gives us our rewriting. This integral becomes the integral over sine of x times 1 minus cosine square of x square cosine square of x dx. The next step will be a substitution. We want to substitute to get rid of sine and cosine, and we've set it up that we can just substitute a cosine. Right? So our substitution becomes that u is equal to the cosine of x, then du will be equal to minus the sine of x dx. Okay, up to a sine, the minus there, we have sine x dx already occurring here, so this is equal to minus the integral 1 minus u squared squared u squared du. As you notice, we didn't expand yet the 1 minus cosine squared squared term. We did this because we now have the term in u, and there it's just easier to write down. Now, simple algebraic expansion. What do we get? We get minus the integral over. Okay. Now we need to expand 1 minus u squared squared. What is this? This is 1, but 1 multiplied with u squared gives us u squared. What's the next term? Well, 1 minus u squared squared, that is minus 2u squared, but again multiplying with u to the 4 gives us minus 2u to the 4. Finally, we get plus u squared squared, which is u to the 4, times u squared is u to the 6. That is something which we can integrate now very easily, namely, because this is a polynomial, the only thing that we have to be slightly careful is that we have a minus sign in the front, that we don't forget copying this. So antiderivative of minus u to the 6 is minus 1 to the 7 u to the 7, but let's immediately do a back substitution. U was the cosine of x, so we get cosine to the 7 of x. The next term, we have the 2u to the 4. The minus here cancels with the other minus out. So we have, as antiderivative, we get 2 over 5, u to the 5. U is the cosine of x, so we get cosine to the 5 of x. Finally, minus u squared, antiderivative gives us minus 1 over 3 u cubed. u is cosine of x, so we get cosine of x cubed plus c. Here we want to integrate x to the 5 times the logarithm of x. How do we integrate this? We would like to get rid of the logarithm. This is essentially a problem which we can do by integration by parts. It's a prototypical problem for integration by parts. To do this, we want in our resulting integral get rid of the logarithm. The derivative of the logarithm is 1 over x. So we want to have we take the derivative of the logarithm. So we have that u is equal to the logarithm of x, and u prime would be equal to 1 over x. This leaves us no choice for v. That needs to be the other factor. So we have that v prime is equal to x to the 5, and v therefore is 1 over 6 times x to the 6. Very good. Doing the action integration by parts, what do we get? We get first the product of the two non-derived factors. So we get the product of these two factors. So we get 1 over 6 x to the 6 times the natural logarithm of x. Minus a further integral, namely now we take the integral over our two new factors. We get 1 over 6 x to the 6 divided by x, which is x to the 5 dx. Well, this is now an integral which we can do very easily, which we can do immediate, namely just copy the first part, 1 over 6 x to the 6 times the logarithm of x minus, now antiderivative of 1 over 6 x to the 5 is 1 over 36 x to the 6